The purpose of this video is to show how the same sensor technology that we use in the Smart Stick proof of concept torque only sensors can be used to perform a torque angle controlled tightening event. What I have here is a Black & Decker industrial grade screwdriver, electric screwdriver that I've modified and put a proof of concept optical sensor into. I purposely put some backlash into the sensor itself so that I can demonstrate how the technology works. As you can see in the center, there's two optical discs, these black optical discs that have apertures in them, and because I have some backlash put into this demonstration sensor, I can open and close the apertures by moving this shaft in a counterclockwise direction. So let me show you real quick how we do a calibration on this, and I have the tool cabled back to the interface box here that is plugged into the personal computer so we can gather sensor signal data and also control the tool and turn it off when we want to. So let me get the computer set up here and select calibrate, and right now there's no overlap in the discs, so there's no light coming from the emitter side to the detector side of the sensor. I'll select OK, and now it's doing a 10-second timeout looking at the detection system. And now it's asking me to apply a calibration torque of 3 Newton meters, and let's just, for example, we'll open up the slots in the disc so they're fully overlapped with the input side disc to the output side disc, and now they're fully overlapped. I'll say OK, and we'll do a rotation and run those open discs by the detection system. Okay, now the computer is asking me to accept the calibration at 0 torque. The detection system has 0 volts, and at 3 Newton meter, 1.4 volts. So I can accept that. And at this point now we're ready to do some torque angle controlled rundowns. I'll stop the camera here and get the fixture that I put together, put on the bench here, and then give you a demonstration of that. Okay, I've got the fixture set up here, and just to give you an idea of what that looks like, it's nothing more than a piece of threaded rod with a nylon cylindrical spacer holding a spring, and that threaded rod, I believe, is 1032 machine thread with a small nut attached on the end there. And I've got the mating socket to the nut here, so I can drop it onto the screwdriver. So right now we're getting ready to do a rundown. The difference between a torque controlled rundown and a torque only, or excuse me, torque angle controlled rundown and a torque only rundown where you're just looking for a certain torque is that you're using a window. If you were to plot torque in one axis and angle in the other, you define a torque window of acceptability, a torque angle window, by setting a threshold torque value. In this case, for this demonstration, we're going to use 1 Newton meter. We're going to say our target torque is 2.5 Newton meters, and the minimum torque angle that needs to be achieved before hitting the 2.5 target torque is 60 degrees, and the maximum angle that can be seen during the event is 360 degrees. Now, the reason for that is you want to be able to determine a good fastening event from a bad fastening event, such as a cross thread or a strip thread, or yielded joint. So you have a well-defined window of angle and torque that can tell the difference between a good fastening event and a bad one. This same technology can be put into the Smart Stick for the tire lane application for lug nuts, if you want to be that sophisticated. So what we'll do right now is perform a rundown. I'll start with the service sequence, the event sequence, give it a name. For right now, we'll just type in some characters. We've got one part to service. This is all configured for tires and lugs, so we're just going to say 1 tire, and we're going to say 3 lugs. Okay, right now the computer's waiting. This should turn blue. And what's going to happen is that when I attach this to the nut and pull the trigger and hold the trigger down, the computer will start looking at the data from the sensor and tell us whether or not we have a good or a bad fastening event. And I'm going to reposition the camera here so you can see this up close. Okay, so you should be able to see the interface box with its blue light, and you should be able to see me attaching this to the screw. The computer's waiting. I hold down the trigger. We've got a good fastening event, and now I have to take that backlash out of the sensor and bring it back to 0 torque. Otherwise, the next event would start, and the computer would see those open apertures and fail the event. Okay, now what we're going to do is I'll continue to drive the nut down the threaded rod. It's waiting for a second event, and what should happen is, because torque is increasing, I should fall out of this acceptability window of angle versus torque, where I have 60 degrees as the minimum angle and 360 is the maximum. What should happen is you'll see the red light come on telling me I failed, that I didn't achieve 60 degrees before I got to the 1 Newton meter threshold. And there we failed. And the reason that we failed is minimum angle was not met. Okay, now I can go back to the computer and say, we'll do that again.